In the interest of time, we will start. Uh, so today what we will see is last week I gave an assignment. Some of you have requested to explain the code for the assignment. So first 15 minutes, we will see the Python code for assignment. And next 45 minutes, we will see today's topic, neural network, I guess. Okay. So we will see, I will explain code by code. So the first we have to load the data set. The package required is pandas. Okay. So okay. So that I have read the data set and stored it in the name of the year. And these are all the packages required for running the linear regression. Okay. So the first step, we will explore the data. What is the data about? Okay. So I'm using a head function. So can anyone tell me what is the use of head function? What it will do? If anybody knows, put it in a chat. What is the use of head function? Yes, Anjali, you are correct. Perfect. Well done. Yeah. So a function, it helps to display the first five rows of the data set. Describe, it will tell about the basic statistics, mean, median, mode for the numerical variables. Okay. Information is also similar. Maybe information is not. And is null function, it will tell whether there is any missing value in the data set. So first we are checking the first five rows, and then we are checking the basic statistics for the numerical variable. And then we are checking how many missing values are there. So, yeah. So this is the first five rows. And we are having an average values, mean, median. We have a mean, standard deviation, and median value. And 25th percentile, 50th percentile, and 75th percentile. 50th percentile is the median value. And then we are checking whether there is any missing values in each column. So in age, there are 10 missing values, and in blood pressure after, there are 11 missing values. So what we are going to do is, okay, so what we are doing is using mean, wherever the missing value occurs, we are going to use the mean function. So mean for age, the mean of the age will be replaced with the missing value. So maybe I will open the data set. Okay. For example, here there is in age, there is a missing value. So in this row, what it will do is, for example, if the mean of the age is 30, then the 30 will be placed. So in this empty box, 30 will be filled. The empty box will be replaced by the value 30. So wherever the missing value occurs in age, the value will be replaced by 30. So at same year, there is a missing value in blood pressure after taking the drug. So here also there is a missing values. For example, here the mean of the blood pressure after is 150. So here also the empty box will be replaced by 150 value. Okay. So for that, what we are going to do is we are going to use a function. So what this function will do is df dot fill na. This is the function to replace the missing value, and we are using the mean value for the replacement. So we are putting the data set name dot mean, and inside why we are giving numerical only equal to 2, because we are checking the missing values only for the numerical column, not for the categorical column. So what it will do is for this code, what it will do is for age, it will calculate the missing, it will calculate the mean. For blood pressure after, it will calculate the mean value, and then it will replace the missing value. Okay. So the basic function of this code is it will calculate the mean for age and the blood pressure after, and then it will replace the missing value with the appropriate mean value. Okay, so why we are putting in place equal to 2 is, if you are putting in place equal to means you need not to assign the data set here. You need not to put df equal to df dot fill that name. So that's why we are putting the in place. If you don't put in place equal to, then you have to put df equal to df dot fill name. Since we have mentioned in place equal to 2, you can remember this. So we have replaced the missing value with the mean value. We will check once again whether there is any missing value. Okay, so if you see now, all the column has a non-missing values. Okay, in all the column there is no missing value. Now we have to check outlier. Okay, can anybody, if you know what is outlier, can you let me know what is outlier means? If you know the answer, put it in a chat. What do you mean by outlier? We have seen it in, long before. What is outlier means? Away from the range value. What is the range value? Range means what? You are partially correct. It is away. It is a extreme value. Okay, away from the normal value. Okay, correct. So it is away from the normal extreme. The outlier is also called as extreme value. Uh, any value that is a extreme value outside the normal range, we will call it as a outlier. Okay. So in our data set, there may be outlier. Okay, for example, there may be outlier in the blood pressure before taking the drug, blood pressure after taking the drug. There may be some outlier in our data set. Okay. So what we have to do is we have to, for example, if the blood pressure is 1000, so in one of the row, if the blood pressure is 1000, that is wrong, right? That is the extreme value. So in that case, what we have to do is we have to either delete the entire row, or we have to replace the extreme value with the mean value. So wherever there is an extreme value, we can replace with the average value, okay, of the same column. So there are two approaches. One is either remove the entire row. For example, if this 148.15 is the extreme value, for example, then you can remove the entire row, or you can delete. You can replace this value with the average value. Either we can do the two approaches. Uh, So in order to yeah, in order to what how we will remove the outlier is there is something called upper limit and lower limit. Okay, so we have to calculate the upper limit and lower limit using the interquartile range method. Okay. So what we will do is we will have we have can anybody let me know what is interquartile ranges? We have seen it in the last class. If anybody knows, let me know what is interquartile ranges. Any guess what is interquartile range? Uh, okay, no, that is not, but good try. Interquartile range is Q3 minus Q1. Okay, maybe I will explain with some example. 1 minute. I will open my slide and then I will explain. Okay. So outlier, what you have to do is you have to calculate the 25th percentage, 50th percentage, and 75th percentage. Okay. So okay, maybe I will show you with one example. So we have a blood pressure reading of 6 patients, maybe. Okay, so we have the blood pressure reading of 8 different patients. Okay, so this is the blood pressure of first patient. This is the blood pressure of second patient. Similarly, we have the blood pressure. Okay, blood pressure reading of 8 patients. Okay, maybe we will consider 7 patients. So now, can you let me know what is the median value here? Can anybody let me know what is the median value here? If anybody know median value, please put it in a chat. 162. Okay. Okay. So 162 is the median. Okay. So that is 50th percentage. Similarly, there is something called 25th percentage. So this is 0th percentage value. This is 25th percentage. Uh, sorry. Okay, so here there are seven values, right? So what you have to do is you have to assume that the 25th percentile value is 148 and 75th percentile value is 180. Okay, so it is simply the position of the number. Okay, assume that this is the 0th percentile and this is the 25th percentile and this is the 75th and the median is 50th percentile. Okay, so so the 25th percentile is 148, 75th percentile is 180. Okay, so interquartile range means 75th percentile minus 25th percentile. So that is 180 minus 140. Okay. That is 32. Okay. So interquartile range is nothing but the values lies between the 75th percentile minus 25th percentile value. So then what we have to do is we have to calculate the interquartile range. Okay, interquartile range is 75th percentile minus 25th percentile. Q3 minus Q1. Okay, so Q3 means 75th percentile. Q2 means median. Okay, Q1 is 25th percentile. Okay. So here, if you see here, this is the interquartile range. In 50th percentile is 162 and 25th percentile is 148 and 75th percentile is 180. Okay. So this is the position of each value. Okay. So here what we have to do is in this our data set, we have to calculate the lower limit and upper limit. Lower limit for formula is Q1 25th percentile minus 1.5 into interquartile range. This is the formula for lower limit. And upper limit is Q3 minus 1.5 interquartile range. Okay. So anything fall beyond the lower limit, we will consider as an outlier. Anything fall above the upper limit, then we will consider as a upper quartile. Anything above the upper limit, we will consider as an outlier. For example, for our data set, if lower limit is 88 and upper limit is 180, so anything fall behind the blood pressure 88, we will consider as an outlier. Okay. So anything lesser than 88, we will consider that outlier. And anything above the blood pressure 180, we will consider it as an outlier. So in this case, what we can do is any blood pressure above lesser than 88, you can remove the entire row, or anything above 180, you can remove the row or you can replace with the mean value. So anything lesser than 88, the lower limit, that will be outlier. Anything above 188, that will be the outlier. Similarly, for age also, you can calculate interquartile range and then find the upper limit, lower limit, and then you can find the outlier, okay, outlier or not. So for age also, there may be lower limit and upper limit. So now what we will do is we will using Python, we will calculate the lower limit. Okay. So what we are doing is Q1 is 25th percentile, Q3 is 75th percentile value, interquartile Q3 minus Q1. So what this code will do is, this is the function code. We are creating one function. Okay. So in this function, what it will perform is it will calculate the quantile 1, quantile 3, and interquartile range. Okay. And then here, anything above lesser than lower limit. So this is the lower limit formula, and this is the upper limit formula. Anything lesser than lower limit, okay, anything greater than upper limit, this will detect the particular row. Okay, so any row has the condition of lesser than lower limit and above the upper limit, this function will detect the particular row. Okay, so whichever row has the lower limit and upper limit, what that function will do is this function will detect the particular row. It may be row number 7 or it may be row number 12. Okay. So what this code will do is this code will calculate the lower limit and upper limit for each function, each column. Okay. So for each column, it will calculate the lower limit and upper limit and detect the particular row. And then what we are doing is we are detecting outliers in two columns. Okay, one is outlier blood pressure before and blood pressure after. So we are checking. So this is just a function. Okay, we are creating our own function, and then we are passing two columns in this function. Okay, one column is blood pressure before and another column is blood pressure after. So we are passing two column in this function. So this function will calculate interquartile range and will detect the lower limit and upper limit for both this column. Then what we are doing is, after that, what we are doing is in this code, what it will do is, so this code, what it will do is in outlier before and outlier after. So whichever row has the outlier in the blood pressure before, that row, only that row will be stored here. So whichever row has the outlier in blood pressure after, only that row will be stored here. So we are creating two data set. One is outlier before and outlier after. So this data set will have only the row which has the outlier. Okay, it won't have every row. For example, so only if the row number 3 and row number 7 has the outlier, then only row number 3 and 7 will be stored in the particular data set. And then what we are doing is, we have identified the list of rows which has the outliers. And then what we are going to do is, so whichever row is detected, we are going to remove that row from our data set. Okay. So this code, what it will do is, this code will remove the identified rows from the our data set. Okay. So our data set name is DF. From our data set, it will remove the identified outlier rows from this data set. Okay. So what we have removed the outlier in two column. One is before and after, blood pressure before and after. Now we are going to use the linear regression. So before using linear regression, we have to find the correlation coefficient. Correlation. Can anybody let me know what is correlation means? We have seen it in 2 weeks before. Can anybody tell me what is correlation means? Okay. So Anjali, you have asked what is, do we have to write the column name for particular row? 1 minute, I will show my code. So here we are writing the column name, blood pressure before and after, right? So this is the place you will write the uh, column name. Okay. So for example, if you want to find outlier for age also, what you can do is, so we have created our own function, right? Detect outliers IQR. So this function will perform upper limit and lower limit. Okay. So this function, what it will do is, this will identify the rows with outliers. So now what we are going to do is, we are going to detect a outlier for age also. So this is the place you have to write the column name. So we are passing the function detect outlier out here, and then we have to write our data set name, and then what is the column name. So if you put the data set name DF and age, so this, okay, so what it will do is, our function will take the arguments df and age, and it will pass it in the function. Okay. So this is the passing of the arguments. So once you pass the argument df and age, so instead of column, age will be here. Instead of column, age will be here. And for age column, it will calculate the quantile 1, quantile 3. For age column, it will calculate the interquartile, and then instead of column, it will replace age, and instead of column, it will replace the age. Okay. And so with this will detect the outlier rows in the age column. And then similarly, if you want to remove, so now we have identified the rows with the outliers in the age column. Okay. So just we have detect the outliers in the age column. Now we have to remove that particular row in from our data set, right? So what I am going to do is, so instead of blood pressure, you write your age column in here. So wherever the outlier row presented, that will be removed in our data set. So okay. So so wherever you have to first give the column name here. Okay, and store it in the name of outlier age, and then uh, in this code also give the column name. Okay. Similarly, if you want to do for another column, you have to give one more code here, and then similarly create one. Uh, Anjali, you got it, or you want me to explain once again? Okay. So this is just a function. Function. We have a function like median, right? So this is the use similar to that we are creating our own function. Okay. So whenever you are using here, that means we are creating our own function. So using our own function, so wherever you use detect outlier IQR, you have to give two arguments. One is data set name and what is the column name. So whenever you give your data set and column name, it will calculate Q1, Q3 interquartile range, and then it will detect the rows with the particular rows with the outliers. So now we have removed the outliers for three column. One is blood pressure before, blood pressure after, and age. So now our data set will not have any outliers and missing values in our data set. And now what we are going to do is now, so all of our column has a numerical values, okay, except one group. One group, it is a categorical variable, okay, control or treatment. When we are using some linear regression or neural network, we can't use the categorical variable as it is. Okay, so what we have to do is we have to encode our variable. So for control, you can put 0. Okay, and for treatment, you can put 1. You have to assign the numerical values for each category. So we will replace control with 0, treatment with 1. So then what we can do is, so instead of control, it will be 0. Instead of treatment, we will have 1. Okay. Reason is for statistical model, you can't use the categorical variable. Okay. You can't pass the alphabet into the statistical. So this code, what it will do is, whichever column name you are giving, that name should be categorical variable, categorical column name we are giving. So this code, it will convert the categorical column into the numerical. For control group, it will convert to 0. For treatment, it will convert to 1. And then we are storing it in the name of DF encoded. So now all our data set will be a numerical values, okay, including study group. Okay, now what we are going to do is we are going to calculate the correlation matrix. Okay, so what we are going to do is we have a data set DF encoded, and we are going to use the method called correlation, CORR. This will calculate the correlation matrix. And then we are creating a graph. Okay, if you simply use this correlation, what it will do is it will calculate the correlation matrix sum in an unstructured form. So it will calculate the correlation matrix in an unstructured way. Okay, maybe it is difficult to read. So I am adding few codes. So our correlation matrix will be in a very structured format. Okay, you need not to change anything here. You can replace as it is. think it's showing some error, but fine. Okay, no problem. So here also we are having a correlation matrix. So if you see the correlation between age and blood pressure, it is showing minus 0.005. It has a very less correlation. Okay. So the relationship between age and blood pressure before is very less. So okay. Maybe before going to correlation matrix, can anybody tell me what will be the independent variable here and what would be the dependent variable here? So anybody, if anybody know what is independent variable, what is dependent variable, let me know. So we have seen it about 2 weeks before. If you anybody know what is independent variable and what is dependent variable, let me know. Age is independent and what could be the dependent variable, what we have to predict here. Okay, maybe I think we have to refresh little bit, otherwise you people will get confused. So we will refresh little bit and then we will go to the code. Otherwise, you will not understand. Okay. So independent variable is something which can't be controlled by any other variable. Okay. It will be independent. For example, the dose. Sorry. Okay. Independent variable is the one where you can manipulate. Okay. The dependent variable is the one where you can't manipulate. Okay. Maybe I will give one example. Independent variable means the column you can control and change. Okay. For example, the drug dose. You can change the drug dose like 5 mg, 10 mg, 20 mg. The dependent variable is that variable that responds to the change and measure. So, for example, based on the drug dose, our blood pressure will be changed, right? So, based on the drug dose is the independent variable. Dependent variable is after giving the drug, what is the blood pressure. So, the variable you can control and change, that is the independent variable. Dependent variable is based on the response of independent variable, what you will measure, okay, what you will predict. So here, after giving the drug, before giving the drug, they are measuring the blood pressure, and after giving the drug, they are giving the blood pressure after. So here, can you tell me what are all the independent variables and what are all the dependent variables? One for one data set, there will be only one dependent variable, but there will be multiple independent variables. Can you tell me what are all the independent variables and what will be the dependent variable? Okay, and perfect, Anjali. So yes, Anjali, blood pressure after is the what you have mentioned. Yes, blood pressure after is the dependent variable and age, blood pressure before, drug dose, study group. These are all the independent variables. Okay. So this is something you can change or control. Age, blood pressure before, study group, drug dose. These are all the independent variable. Dependent variable is something you are going to predict or it is the response of the independent. So this is what we are going to predict in the linear regression. Similarly, in so what we have to do is we have to find the best independent variable for our dependent variable. Okay. So based on your domain knowledge, can you tell me what would be the perfect independent variable for the blood pressure after variable? So can you, based on your biological knowledge, can you tell me which independent variable will contribute more to this dependent variable? Dose, correct, perfect. So the drug dose, maybe if the drug dose is lower, the blood pressure after maybe there won't be any change, okay. But if the drug dose may be higher, then there may be a change in the blood pressure, okay. So this is before taking the blood pressure, before taking the drug, what is the blood pressure? And this is after taking the drug. So there should be a change, right? So after taking the blood pressure drug, the blood pressure is dropped from 162 to 146. So here 154 to 141. So if the drug dose is higher, the change will be also much higher maybe, or it may be a vice versa. So the drug dose may be the perfect. And age also one may be the a powerful independent variable. Okay, maybe higher the age, the blood pressure may be, the drug may not be working better. If the age is more, the drug may not work as efficient for the younger population. Okay. So age is also one of the contributable independent variable. Study group also may be one of the independent variable. Okay. Even blood pressure before also may be one of the independent variable. What is the pre-baseline value? So these are all the independent. I think before going to the code, you should know what is independent variable, dependent variable. Otherwise, this you will not understand the code. Okay. So maybe we will take some questions. Then you will understand. So can you let me know what is the independent variable here? The pain relief score, dose of the medication, patient age, time of the day. What would be the independent variable here? Okay, see, okay, okay, perfect. Age can be the independent variable. Okay, so the dependent variable is, see, you have to read the research question first, okay? They are checking what is the impact of new pain medication on the pain. So the pain relief will be the dependent variable, and another variable is new pain medication. Okay. So the pain medication. So now read the research question and tell me the pain relief is the dependent variable. Then what is the independent variable here? Yes, dose of the medication. Perfect. So now the clinical trialists investigate the effect of exercise on the blood pressure, which is the dependent variable here. B. Okay, blood pressure readings. Perfect. B is the correct one. Okay. Yeah. Okay. The pharmacist is studying. Okay. The pharmacist is studying how much different temperature affect the stability of the drug, which is the independent variable here. So they are checking how the different storage temperature affect the stability of the drug. So which will be the independent variable? Yeah, B is the correct one. Storage temperature. How the different storage temperature, stability of the drug will be the dependent variable. Okay. Okay. I think that's enough, I guess. So now another thing is, so there may be multiple independent variable which can contribute to the dependent variable. So age is also one of the independent variable. which can contribute to the blood pressure after. Drug dose is also one of the independent variable which can contribute the dependent variable. Okay. So there may be a multiple independent variable and one dependent variable for each research question. Okay. So we have to know which independent variable contribute most, right? So for that, we will calculate the correlation value. Okay, we will calculate correlation for each independent variable and dependent variable and independent variable. So what we will do is we will calculate the correlation for each independent variable versus dependent variable. So our dependent variable is blood pressure after, right? So we will calculate the blood pressure after versus age. We will calculate the correlation for blood pressure after versus drug dose. And we will calculate the correlation for blood pressure after study treatment. Okay, then we will see which has the highest correlation. Okay. So can you tell me which has the highest correlation, which has the highest contributed dependent variable here? So for a correlation, we are calculating correlation between the dependent variable versus each independent variable. Okay. So blood pressure after versus age is minus 0.003, the correlation value. The blood pressure after versus blood pressure before, the correlation value is 0.91. Okay, blood pressure after this is a this one you should not consider because both as the same variable. So the obviously correlation will be one. The correlation value for blood pressure after versus drug dose is minus 0.01 and correlation between blood pressure after study group treatment. Okay, so these are all the correlation values. Okay. Now if the correlation value is 0, then there is no correlation. Okay. If the correlation is 0, that means there is no relationship between the independent variable and the dependent variable. If there is the correlation is 1, then there is a perfect relationship between the independent variable and dependent variable. Similarly, if there is minus 1, then also there is a perfect relationship between the independent variable and uh, dependent variable. Okay. If it is lesser than greater than 0.5, there is a good relationship. If it is lesser than 0.5, then there is a mild relationship. If there is 0, then means there is no relationship at all. Now tell me, these are all the correlation between blood pressure after age and blood pressure after before and after. Okay, and then blood pressure after versus drug dose. Can you tell me which independent variable has the highest correlation versus the dependent variable? So go through the correlation table and tell me which independent variable has the highest correlation. So tell me which independent variable has the highest correlation value, which one has the highest contributing factor here. Uh, Okay, perfect. Trisha, perfect. So for blood pressure before, the correlation value is 0.91. Okay, so this has the value near to 1. So one of the independent variable we can consider is blood pressure before. Can you tell me which has the second best correlation value here? Second best correlation value. So the second best correlation value is drug dose, okay, minus 0.12749. No, age or, yeah, uh, I think, age, no, I think the study group treatment and drug dose. So the first best correlation is, the perfect correlation is blood pressure before. So this is the highest contributed independent variable. The second best correlation is minus 0.07. Even this is lesser than zero point 0.5, but still we don't have other option. The third best independent variable is minus 0.1. Okay. So what we can do is we can take best three independent variable in our linear regression. Okay. So what you can do is, for X, you have to give the independent variable list. Okay. So what I am doing is I am giving three best independent variable. One is blood pressure before. So X is independent variable and Y is the dependent variable. Okay. So in the place of X, you have to list down all the independent variable. And third best independent variable is study group treatment. So using correlation matrix, we are finding which independent variable is best based on, you can take three independent variable or two independent variable based on your wish. And okay, and our dependent variable should be blood pressure after. Okay. So in X, what you have to do is you have to list down the independent variable, and Y, that is a dependent variable. Okay. And what this code will do is, if we are initiating the linear regression here, you need not to worry about this code. If this is your wish, you can give or you can omit this code. And then we are initializing the linear regression model. And then we have to use the model.fit. We are fitting our independent variable and dependent variable to our model. And then we are making a prediction for dependent variable. Okay. So then using the linear regression model, what we are doing is we are going to make a prediction. Prediction means, I will explain once again. This is so this is the blood pressure after, right? Before, after. This is our dependent variable. So using linear regression, y equal to mx plus c. M is the slope and X is the independent variable. So based on the linear regression form equation, we will make a prediction for blood pressure after. Okay. So using the linear regression, we will make a prediction. So this may be year one, the actual blood pressure after is 146. So here also, if it is our prediction also 146.68, then our linear regression model is good. Okay. But if our prediction is 120, if there is a huge difference between the prediction and the actual value, then our model has some error. Okay. So if the difference is huge with the actual value and the prediction, that then our model has some issue. Okay. So similarly, here the actual value is 141. Here also, if there is 141 after prediction, then our model is good. But if the prediction is 200, then there is a huge difference. Okay. So how to evaluate the linear regression model? Okay. So what we will do is we will calculate something called R square. Okay. R square is nothing but square of correlation value. Okay. If your R square is 100 percentage, then your model is 100 percentage accurate. Okay. If your R square is 90 percentage, then your model is 90 percentage accurate. So we will see what is the accuracy of our model. So our accuracy is 0.83417. Okay. So using our model accuracy is 83 percentage when we are using three independent variable. Okay. Now I am thinking maybe study treatment group I don't want to include in the model. I want to include only two independent variable. Now I am going to see what is the R square for that. Okay. Now my R square became 83. Initially it is 82. Now it became 83. Okay. Uh, Suppose if you keep only blood pressure before, okay, similarly 83. Okay, so what you can do is you can change the independent variable and then you can check the what is the best independent variable. Okay. So you can try with the different independent variable and then you can see the R square value. Okay. So whichever R square is best, that model is the best model. Okay. So maybe you can consider using two independent variable. You can consider three independent variable. Okay, and then you can create a linear regression model. So based on the R square value only, we will decide whether the model is perfect or not. If your actual value and prediction values are same for all the rows, then your R square will be 100%. But if it is 50 percentage error means then your R square value will be 50%. Okay. So based on the R square value, we will decide our linear regression model is good or not. Okay. That's it from my side. If you have any questions, let me know in this assignment. If you have any questions in this code, let me know. Or even if you don't understand, you can contact me on WhatsApp also. I will be happy to help. I think time is already over. Maybe I thought to cover a neural network model. It may take 1 hour time. So maybe next week we will keep one more additional class to wrap the things little faster. Only for next week. So maybe next week we may have two classes, I guess. Okay. In order to wrap the topic little bit faster. Okay, so you want to know how to do the predictions, right? Okay. Okay. So that in linear regression, uh, for example, there is one code. Okay. So you want to make a prediction now. Okay. What we will do is, what is your model name? We are giving the model name simply as a model. Okay. So then what we have to do is, we have to give model dot predict. So what you have to give your model name. Suppose if your model is model 1, then you have to give model 1 dot predict. Okay. Then okay now okay. So similarly, my model is simply the model. Then you can put predict. Okay, and then here you have to give your sample input. Okay. For example, so here you have to give your independent variable. Okay. So you have to tell okay, I am taking three independent variable. So the age for the I want to predict the make a prediction for first row. Okay. So what I am going to do is I am going to use age 58, and then I am giving another independent variable, blood pressure before, for blood pressure before 174.34. And then another independent variable. We have taken three independent variable, I guess. Drug dose also 21. Okay. So this will what it will give us, it will predict the value. Okay, I think okay. I think we have to give the input in a different format, I guess. Maybe I will share the code, but this is the function using this model dot predict, and then inside you have to give the independent variable value. Okay, so this will make a prediction and it will give the prediction value. Okay, what is the using y equal to mx plus c? You can it will make a prediction based on this equation. Okay, maybe I will share the code how to give the later, but this is the function which will use to make a prediction. But if you want to display what is the slope and intercept, what you can do is, if you want to know what is the slope for age, uh, okay. So this is the, for example, yeah, I think we have taken only one independent variable. So that for one independent variable, for blood pressure before, we have taken blood pressure before. For that, slope is 0.91. But in your model, if you have taken two independent variable, maybe here 0.916 comma another slope value will be given here. Okay. So using model coefficient, you can display the slope value and intercept. What is the intercept value? So these are all this will display the slope and intercept value. Okay. If you want to predict, you have to give model predict, and then inside you have to give the independent variable value. Okay. Perfect. Okay. Perfect. And based on the R square, you will decide which model is better or not. Okay. I think we will have two classes next week. If you have any questions, let me know. Otherwise, we will close the session now. Okay. Thank you. Thank you, everyone. It's next week.